Hello everybody, I am here tonight working on Unit 2, and tonight we're going to be doing a bunch of different things. One of the things we're going to be working on is the homework that's listed in Unit 2, and what you're going to see is it's going to be a repetition of the whole process of both problem solving a problem, converting it to pseudocode and flowchart, and then I'm hoping by the end of the evening we get to actually getting into Visual Studio and beginning to code a solution for it as well. But I'm also going to take a little bit of time to talk about some things in the course shell that you should be aware of. The one thing is, and I just added it, so I'm going to pull it back onto my screen here. It's actually on my second screen. Is the fact that if you go to the resources page, left-hand side menu, you're going to see that I added an entry here. I finally took the access code that's in my copy of the book and I created my own student account on the website so that I could access the student resources, and then what I did is I downloaded them and added them to the course shell. So sometimes, you know, when you buy used copies of the book, somebody's already used the code and you can't get in there and get those things. It's not really anything all that special, honestly, but there are some cool files there. So it's the second entry that you see here. And if you notice that there's a couple of zip files, the first two zip files, one is actually a zipped up version of program solutions from within the book. And also solutions, the second one, to some of the problems in the book for odd numbered exercises. So the hope there is that, you know, if you're wanting to kind of reinforce your skills, I obviously won't assign the ones that already have the answers out there, but if you want to learn how to do something, or if you're curious how they did it, or you want examples on how to do something, you can go in there and you can pull out a working program and take a look at it and see how they accomplish something, and you can get ideas for doing your own stuff. So I think that's kind of a handy resource. The third link there is actually a zipped up version of all the PowerPoints, the same ones that I post with each unit. So every time I put a new unit out there, I'll add a chapter PowerPoint. But if you want them all at once in advance, you can just download the zip, unzip them, and you have the whole book's worth. So, and that's up to you. That's not an obligation to download them. I just want to make you aware of that. The other cool thing is if you actually go to the website that they have, the companion website, and I'm hoping I'm going to the right link here, and you log in and you actually get into the resources here, and that's what I'm trying to find. There we go. You will have to create an account basically with the access code from the front cover of your book. You create a login, and not only can you download the same stuff that I just put out in the course shell, but they also have access to all the video supplements that come with the book, and that's what I'm trying to locate right now. All right, well, these are the instructor resources. You guys don't want those. So if you give me just a moment here, I must have it open in my other browser. Here we go. All right, so once you get all logged in and have an account, you basically get access to this page here. And you can see that the first link that they provide are the video notes. And I don't know if you guys have noticed it when you're reading the book, because you're all spending all your time reading the book, right? You should. I mean, you pay a lot of money for it. Honestly, I think that it's worth reading. But every once in a while, you'll encounter in the book, like in the margin usually, a little thing that says video note. And the author does the same thing I do. He goes through and he creates videos about how to do certain things. And this is a complete listing of all of them. And I think a lot of them are pretty helpful. I won't play them in class because you guys can do that on your own. But I just want you to be aware of the fact that they're there. And that, you know, that's one of the reasons why when you get a textbook like this that costs a pretty penny, why you pay so much, because it comes with all that extra stuff. And I think that that's very helpful. Okay, the other thing I wanted to talk about was something that I did not mention in last week's class, and I'm going to actually take us back to Unit 1, and I'm going to look at this handout that I have here. This handout's available on the resources page and in Unit 1. I put it in both places. And I don't know how many of you actually took the time to to open up the document and read it, but I'm going to bring it up on screen right now. But I think this is a pretty handy little document, and actually not a bad thing to kind of keep off to the side somewhere if you're ever like kind of confused about how to proceed, or you want just a little refresher on what the process is. This is kind of a nice little document, I think. So it says, at its core, computer science is the art of solving a problem in a methodical way. And hopefully I've taught you that already. There's usually more than one way to solve a problem. However, some solutions are better than others. The best solution generally is a solution that is both efficient and easily understood by others. A simple solution that is inefficient will produce a slow program that frustrates users. On the other hand, the most efficient solution may be so complex that other computer programmers may have difficulty understanding our work. It is important to kind of strive for balance. So you might kind of question in your head, how do you write a program that's so efficient that it's hard to understand? Well, think about like when we were doing the math for the fertilizer problem, right? We discovered that you do, was it lawn area, and you divide by 9, and then you got like that area and divide it by 9 again, right? And really, the truth is, if you divide by 9 twice, you may as well just divide by 81 because it's the same difference, right? You get to the same answer. However, if you're not sure how you got from point A to point B, you know, somebody's not able to follow your logic. Why are you dividing by 81? That makes no sense to me. It's of no use to somebody who's trying to pick up on your program and edit it. And that's kind of a primitive example, but you can write like algorithms where you can have like one mathematical statement that will do all the work for the whole program and come up with the answer you need, but there's nothing incremental in between to give the explanation of what's happening. So there's kind of a balance that happens. But ultimately, let's take a look at the little guide I have here. It says a simple method to problem solve for computers. Understand and analyze the problem. So in the first thing is part A, it says, what is the program trying to accomplish? I'll tell you what, if you don't have that firmly in mind, there's no way you're getting there, right? So you have to know what you're trying to do. Then you do the basic, what inputs do I need in order to be able to figure out the problem? And then ultimately, what kind of output am I going to create? And then it says, what format is the data in currently? And does the data format need to be changed? And we'll talk about that as we do our stock sale problem here in just a little bit. Step 2 is create a general outline of the steps that are needed to solve the problem. So start from the general and then move to the specific. That's kind of the thing. How do we do that? We use pseudocode and flowcharts. Once you have what you think is a solution, and that is whether you've pseudocoded it or flowcharted it or both, you got to test that solution. So you got to be able to give it values that you know are going to calculate correctly or make the right determination to come out with the solution that you need. Once you think your source or your pseudocode, excuse me, is correct, then you can start converting that into a program. Now, notice that last one. It says test the program to ensure correct operation. Right? Well, if you know what kind of answers you should get from a thing because you worked out the equations ahead of time, you should know basically the kind of answer that the computer should bring back to you. And if you're getting something different, then it really kind of points out some sort of a issue. And notice the 3 bullets there. It says pay specific attention to testing transition points. So I'll show you what that is as we go. Run a bunch of different type of data through the program, and then repeat the process after making corrections. So sometimes pseudocode gets you close. I mean, ideally it'll get you right there. So all you have to do is convert from pseudocode to regular code. But then sometimes you'll discover that, well, this is how you solve the problem, but the programming language kind of handles numbers differently and inputs differently, and I have to make some adjustments to really get what I need. And that comes with experience. But I think this is kind of a handy little handout that if you're kind of stuck in the process that you can refer to and hopefully get maybe a little bit of clarity out of it. All right, so with that, folks, I'm going to move us back over into the Unit 2 folder. I do also want to remind you, if you haven't taken the quiz yet, please take the quiz. It is based on Chapter 1 material, so it's all about pseudocoding and flowcharting, problem solving. Pretty simple, open notes, open books, got to be done by June 1st at midnight. That is 2017. All right, so I'm going to actually scroll myself down here to the stock sale problem. And the first step of this is going to be to do the pseudocoding and the flowchart. And for those of you here in the classroom, I'm going to describe the problem to you here in detail as we start, as we do this video thing that I'm doing now. And then I'm going to let you guys get together in pairs and try to work through a solution. And then we'll kind of take a look at what solutions you came up with and see if yours makes sense compared to somebody else's. And then I'm also going to show you how you guys can have very seemingly different solutions that actually get you to the same place. So that's kind of fun to do that comparison. So I'm going to begin by just opening up this Word doc here, and I'm going to read the problem to you. All right, so the instructions are, it says write a pseudocode solution and a flowchart solution for the following problem. So you got to do both. Here's the scenario. A customer buys a stock from us. Customers do not pay a commission to buy stock, but rather they're going to pay the commission on the back end. Okay, so when they sell the stock. So it says at some later time the customer sells all of the stock at a new price. This is at a 2% commission. Our pseudocode should calculate how much the original purchase was, the value of the stock sold, and the commission on the final sale. It should then calculate the customer's profit or loss, right? Because sometimes you sell at a loss. And the idea is that someone bought stock from us and we want to calculate what they paid. Then they sold the stock and we want to know how much they sold it for and what our commission was. We also want to know the profit. Now that's kind of a reiteration of everything I just said, right? But I'll tell you what, when you're a computer programmer, sometimes you'll go into a meeting and people aren't going to come to you with pseudocode. They're going to come to you with an idea. Maybe an idea just like this, and they might state it and restate it a few different ways. And then it's up to you, based upon whatever notes you took or what information you thought you heard, to kind of create something that matches what they're looking for. In this case, we actually have a written description with very specific details. So as I get you guys to pair up and work on this for a little bit, what I want you to do is look very carefully at the details listed here and then come up with that solution that will match up. All right, so I'm going to actually pause this video. I'm going to let you guys work on it for a while, and then we'll talk about it some more. All right, after a good long bit of time here, maybe about a half hour or so, I had all the groups in class present their pseudocode solutions, and we talked about them. And then I showed them my flowchart that helps to solve the stock sale problem. And so what I'm going to do here, while I have the flowchart on the left-hand side of the screen, is I'll talk through basically my approach for pseudocoding and the terminology that I would use. And remember, this is pretty subjective. Pseudocoding is a problem-solving process, but you'll discover that as you get better at it, you'll start to pseudocode in a fashion that looks more like a programming language as you learn to do it more. And in many cases, if you do it in a certain fashion, in some cases you can pick up the math and the variable names and move it right over to your program. So that's kind of a handy thing. But the key to solving any problem is really being able to read the problem honestly and understand it. And as a number of the students in class pointed out, it's like, what are they really looking for here, right? Because it's not really worded in the best possible way. And that's actually by intent, folks. Because when you're working with a client, whether it's an internal client at some company that you're working for, an external client, or some person that comes to you and says, hey, I want you to build me a piece of software. Not that that would be very likely, but that's possible. You don't know, or they don't know the terminology of programmers, and they only know what they want to get. right? So they'll explain it to you in terms that make sense to them. That might not be exactly what they're, you know, exactly something that breaks down into pseudocode real cleanly. But what I'm doing is I'm putting this back up on the screen here and just kind of pointing out facts. It says a customer buys a stock from us, all right, because we're a stockbroker, right? They don't pay a commission to buy, but at some point they sell the stock at a new price, and then that's at a 2% commission. And of course, as we were discussing in class, the ideal is that you buy for one price, you sell it for a little bit higher, and then after they subtract the commission, you're still turning a profit. That's what you do with stocks. All right, so the pseudocode should calculate how much the original price was, the value of the stock sold, and the commission on the final sale. It should then calculate the profit. And it says the idea is someone bought the stock from us and we want to calculate what they paid. It's pretty simple. And then sold the stock, we want to know how much they sold it for and what our commission was. We also want to know the profit. Isn't that just saying the exact same thing again? Absolutely. That's how people are when they describe problems to you, especially if they don't know what they're talking about in terms of the technology that you're working with. You know, and people that work on the hardware side, you'll probably say, I just want something really good to go on the internet and watch Netflix. And, you know, you can give them all sorts of advice based on that information. But if you find out later that they want to do video editing, you'd probably push them towards a different piece of hardware, obviously, right? Something with a decent graphics card, which you probably wouldn't get in a low-end machine. But if they didn't give you that information up front, how would you know what to suggest? So you see like the mindset that goes with that. All right, so that aside, the first thing that I looked at was, and the same thing that both of the groups here in class identified, was the fact that we would need basically to get the purchase price from the customer. And I might even just say, get the purchase price. Or I might even like simplify it even further. I mean, you can see in the flowchart, it just said input purchase price. So I'm just going to leave that as get purchase price. And then the next thing we have to do is we do need two inputs. So, and we also need the selling price. We already know that the commission is equivalent to 2% of the selling price, right? And really, to calculate the commission, what do? You multiply, right? So that's the thing you can do right off the bat. Now, profit, that's the one that maybe can stump you in some circumstances, especially if you're not a business major. Because profit really is, you know, what you sold something for, you subtract what you bought it for, and hopefully that's a positive number, right? But in this case, we would take the selling price, we would subtract the purchase price, and then we would also subtract the commission. So all three of those things. And the example I was giving here in class is, let's just imagine now that, and I'm going to do this in parentheses here just like for test numbers, we bought the stock for 90 and 100. Now you don't have to include values like that in the margins. I'm just doing it there so that when we come back to it, we can figure it out. And then if we were to take the selling price times 2%, you do the math on that, it's 100 times 0.02, that comes out to 2. And then ultimately this equation here would be 100 minus 90 minus 2, and what's left over? 8, right? So there's $8 left over. So the profit actually ends up equaling 8. which is good. As long as you turn a profit, it's considered good. And then finally, since we have all the information, then you would just output. What would you output? Well, it told us that we want to see, we want to know how much they sold it for and what our commission was. We also want to know the profit. And as one group put it, what did you guys say? Display commission, profit, and selling price, right? And that's what I would do. I would output all three of those things. And it looks like when I did my flow chart here, I didn't do all of those. But I would output to the screen, and if you don't want to say output, you could always say display, profit, commission, and selling price. That's not really a lot of pseudocode, is it? It's pretty simple. And you know what? This problem is intended to be pretty simple. Now, if you write up your pseudocode in this fashion, you'll be fine. If your flowchart looks kind of like that, you'll be fine. And I realize I'm kind of giving you guys the answer, and that's really part of the process here. The online people aren't going to get the answer as quickly as you guys got it because you already worked through it here in class. So I'm going to let them work on it a little bit, and then I put the answers out right before the due date. But as we move through the course, I'm going to give you fair warning. I'm not going to be putting answers out before due dates. It's just at the beginning of the course so you guys kind of get up to speed. But I will be posting solutions for everything that we do in the class. So just so you know that. All right. That basically is the first part of it. Now I'm going to be recording a separate video in the near future here that's going to talk about kind of a stepped up version of this program. So this video that we're listening to now, this is going to end, and I'm going to create a fresh video on the second part of it, and that's what we're going to be doing in class right now. So this video ends here.